Welcome to VMware's demonstration. Built for partners. Accelerate development of O-RAN applications using a RIC SDK. This demo illustrates how RIC SDKs help partners jumpstart their applications development by removing the complexities associated with networking and communicating with the different elements of an O-RAN deployment. VMware's vision states that RAN intelligent controllers are the key to unlock openness and monetization of the RAN, as they provide the necessary abstraction that removes the challenges of having to directly integrate applications with the underlying data plane. In addition, VMware believes that this RAN intelligent controller must be built with partner and developer experience at the heart of its design. Therefore, offering an SDK with a set of resources, tools, and services that will help accelerate their XApp and RApp development, enhance portability, and increase security on RIC platforms. The RIC's SDK is a logical extension of the RIC, and it is composed of a set of libraries and data structures designed to abstract the user applications from the complexities of networking and communicating with the RIC, E2 nodes, and with other applications. To access the SDK, simply download the kit and extract the files. The main components of the SDK are the SDK libraries, the APIs, the reference XApps, which are starter applications to help accelerate the development of the XApp, and the starter Kubernetes custom resource definition for the application, used to describe the XApp and manage its security aspects. The SDK libraries are shared in the form of an archive library and abstract the communication with the RIC and the E2 nodes by means of simple function calls. The APIs, built as C and C++ data structures and invoked as header files, provide the points of entry to the SDK libraries. Each API is independent of each other and fulfills a specific role in the interaction between the XApps, the RIC, and the E2 nodes. To further enhance the usability, all the APIs make use of a common header file containing the four main communication functions needed to interact with the RIC and the E2 nodes. These functions are poll, used by the application to query the RIC about pending messages to be read among the E2, management, or utility interface. Read, used by the application to read a pending message for a specific API. Write, used by the application to write an outgoing message to the E2, management, or utility interfaces. And free, used by the application to clear up the memory of processed messages. Then, each API has one or more additional header files that are unique to the interface and contain the definitions of the data structures that the application uses to communicate on the API. For example, the API file s2xe2.h contains all the data structures associated with the E2 interface. The main structures of this file are the E2 message to XApp and E2 message from XApp, which are used to construct any incoming or outgoing E2 message. In this case, the outgoing messages from the XApp are subscription request to E2 node, subscription control request, and subscription delete request. Each invocation of any of these messages will be parametrized to make it unique. For example, subscription request will clearly identify the E2 node ID and will associate it to an XApp ID. Any further communications between the XApp and the E2 node can easily be identified. The management API is used to control the communication between the XApp and the RIC. Through this API, the XApp can be registered with the RIC and access the services provided by it. To get access to the RIC and E2 nodes, every XApp will use the registration request construct and will wait for a positive registration response from the RIC, even before any subscription to an E2 node can be issued. The registration process will mutually identify XApp and RIC. In this next section, VMware proposes a very simple methodology, powered by the SDK, that can accelerate the development and onboarding of an XApp. The starting point is the modification of the reference XApp provided with the SDK. This reference XApp has been designed to facilitate the communication between the XApp and the surrounding environment. Structured in three areas, the reference XApp first initializes the application by initializing the SDK and registering with the RIC. Then, based on the new application's requirements, the reference XApp will activate the necessary subscriptions to the E2 nodes. From this moment on, the SDK will be handling all communications with the RIC and E2 nodes. thus allowing the developer to only focus on the main purpose of the application. The next step in the methodology is to pull and run the XApp development container provided through the partner's Docker registry. We will now use the Kubernetes custom resource definition file provided with the SDK to set up the security, permissions, and resources for the XApp. Finally, we are ready to build the XApp and its Docker image. In this last section of the demo, we are going to deploy and run the newly created XApp. The following setup has been created for demo purposes. Running on VMware's Telco Cloud Platform RAN, we have deployed a RIC instance and a test E2 node that will act as a termination endpoint on the E2 interface. The XApp will then use the SDK to register with the RIC and initiate communication with the underlying data plane. The first step to launch the application is to set up the Kubernetes environment by modifying the descriptor files. The first one to modify is the provided XApp reference YAML file. We will use this file to point to the image of the XApp in the partner's registry. Then, we will point the SDK to the RIC instance to use by parsing the RIC's IP address and port via the SDK YAML file. Now we're ready to launch the XApp. Executing the kubectl command, the XApp launches, and we can see the pod created. The next kubectl command will capture the logs associated to the XApp execution. The logs show how the XApp first tries to register with the RIC, and upon receiving a positive response, it subscribes to E2 node events and receives indications from the RIC as events occur. To summarize, we have first shown the components of the SDK and how these components have been designed to simplify the interaction among XApps, RIC, and E2 nodes. Then, we have proposed a very simple methodology to develop XApps by using this SDK. And finally, we have shown an example of deployment of an XApp on a RIC. Our ecosystem partners can now focus on developing and bringing their new applications to the market faster.